We can start.
Okay. Okay, so hello everyone. Thank you for being here and thank you to the organizers for inviting me. My name is Elisa. I'm currently doing my PhD at the University of La Serena in Chile. And today I'm going to talk about my work of dark matter-deficient galaxies using the Illustris-TNG simulations that I'm currently working on with Claudia Scocco. And so here's an outline of my talk. I'm going to start with the context and the motivation that drew us to study this type of galaxies. Then I'm going to talk about the methodology that we used. And well, afterwards, I will characterize the sample of the galaxies and tell you something about the results we got so far. And well, I'm going to finish with a summary and the conclusions. Well, as you all know, in the lambda CDM model, the standard cosmological model, the dominant mass budget of the universe is the dark matter. And even low mass galaxies are expected to be dominated by dark matter, at least in their central regions. But recently, there have been some observations that suggest that some dwarf galaxies and low mass galaxies have a very low dark matter fraction. So in comparison with the normal galaxies, these other galaxies would be dark matter deficient. And this, well, it's an interesting point and makes them an interesting object of study. And there are currently some studies in the literature that address this problem using hydrodynamical simulations, such as Eagle and Illustris and New Horizons. So in this work, we are using Illustris-TNG to analyze this population of galaxies. And as some of you may know, Illustris-TNG is a state-of-the-art cosmological simulation that consists in 3 boxes of different cubic volumes, where you can follow the evolution of the different components, and they have a very good resolution. They are high in resolution in mass for every particle. So we used the TNG 50 in this work because it's the one that has the better resolution. And we decided to study some basic characteristics of the dark matter-deficient galaxies at redshift 0. And afterwards, we tried to explain or find out about a possible formation channel for these galaxies. Well, so firstly, the dark matter fraction is measured as a ratio between the dark matter that a galaxy or subhalo has and its total matter. So dark matter deficient galaxies are those that have a dark matter fraction below 0.5, below 50%. And in this work, we classified, we chose to study on one side the total amount of mass that these galaxies have. So we got a dark matter fraction, a total dark matter fraction. And on the other side, we decided to study the dark matter fraction within their central regions. So in order to do that, we used the parameter half mass radius. And well, for those who are not familiarized with this term, it's the radius that contains half of the mass of the subhalo. In this case, we use the stellar half mass radius, so it would be the one that contains half of the stellar mass of this galaxy. And well, at redshift 0, we have a sample of more than 10 million halos in total, and more than 5 million subhalos. And here I'm showing you the mass function that is, well, very well behaved. It decreases for high masses, and we have this decrease over here at low masses because unfortunately the resolution is limited. So we have completeness issues for low masses. And well, for this work, we considered the following criteria. We used the subhalos that have defined stellar half-mass radius, because we wanted to, on one side, study the matter inside this radius, twice this radius. And on the other hand, we chose to study the subhalos that simultaneously have a cosmological origin. And this is because there are some substructures in the simulations that do not have a cosmological origin, so they would not be galaxies that formed during the process of structure formation and gravitational collapse. And once we established these conditions, we found, we calculated the dark matter fraction for the subhalos that met this criteria, that those were more than 98,000. And we found that there are 806 dark matter deficient galaxies within their central regions, and 337 dark matter deficient galaxies when considering their total amount of mass. And well, here I'm showing you the mass function for only the subhalos that have met these criteria, these two conditions. And well, in green, you can see the subhalo mass function for the dark matter deficient galaxies within their central region, and in orange, those that meet the dark matter deficiency condition using their total amount of mass. Sorry?
5 more minutes.
Okay.
Question.
Okay. So to show you some results, once we calculated the dark matter fraction, we decided to plot the dark matter fraction within their central regions, and the one that we got when using the whole amount of mass of the subhalos. And well, here, as you can see, those galaxies that turn out to be dark matter deficient when using all of their mass tend to be low mass galaxies. Here, as you can see, we have a color bar, and the darker the colors, the less massive the galaxy is. And well, the ones that were only dark matter deficient within their central regions are more massive galaxies. And to try to show some examples and explain a possible formation channel, I'm showing you here 2 examples of the evolution of some subhalos. In this case, we have dark matter deficient galaxies that are deficient when considering their central region. And in the first panel, you can see the distance between this subhalo, this satellite subhalo, and its host. And in this other panel, you can see its dark matter fraction, and it's in the third panel, their baryonic mass, and in the last panel, their dark matter mass through time. So the first redshift that you see in each panel, it's the redshift at which the subhalo starts being satellite. It's their last accretion. And while they evolve, as you can see, the dark matter fraction starts to decrease, but only in these cases, the one that decreases and reaches a deficiency and passes through the threshold is the dark matter fraction when considering the central region, because when you consider the total amount of matter that this galaxy has, it's a perfectly normal value, close to 1. So the dark matter really dominates this subhalo. And these pronounced decreases you can see that may catch your attention. Those are due to some failures in the simulation when they have to identify the particles of the satellite subhalo and the central subhalo when they are too close. So that's why it decreases abruptly, but then, as you can see, it's not really such decrease. Moreover, we have the other type of dark matter deficient galaxies that we studied. And in this case, as you can see, the dark matter fraction, considering the total amount of mass, really decreases. It has a general decrease following the general decrease in distance between the satellite subhalo and the central subhalo. So what we think that may be happening is a tidal stripping scenario that passes through time, and when the satellite comes really close to the host, it loses some of its dark matter. So to sum up, I'll leave you with these conclusions, but well, mainly what we found is that dark matter deficient galaxies are allowed in currently formation models because the Illustris-TNG simulations use the lambda CDM model. And well, that these population of dark matter deficient galaxies are generally low mass galaxies. And well, the dark matter fraction decreases mostly when the distance between the subhalo and the host halo is it's the minimum along its orbit. So well, a tidal stripping scenario is well suited to explain this behavior. And well, as we can also think that the one type of galaxies that are dark matter deficient when considering their central regions and not when considering their total amount of mass are not really dark matter deficient galaxies, but they're dark matter that was placed in the central region got misplaced or got placed outside the central region, and it's now part of the halo. So that's why it has a deficiency in the central region, but it's not deficient when you consider the total amount of mass. So that's it for me. Thank you very much for listening. And if you have any questions, I will be happy to answer them.
Elisa, we thank Elisa. Okay, we have one question here and another from the online.
Hi, Elisa.
Hi.
This is Karim from the audience from Malongo in Brazil. This was very enticing work. So I have a question because I've been starting to dive into Illustris myself, and I was interested when you said that you eliminated all the subhalos that had no cosmological origin. How do you actually do this? What parameter do you use?
There is a flag, a subhalo flag in the Illustris-TNG simulation. I think the name of this field is subhalo flag. That, well, it tells you if the subhalo has a cosmological origin. If this flag equals 1, it's cosmological origin, and if it equals 0, it's not cosmological origin. Because there are some structures that may have formed due to, for example, collapses or mergers between other galaxies, and it remains a clump. So this galaxy would not have a cosmological origin because it didn't form due to structure formation. So we wanted to make sure that these galaxies that we are studying are actually galaxies that formed due to gravitational collapse and not due to the remains of some merger. But there is a flag. You can look for it in the Illustris-TNG database website. I think the name was subhalo flag.
Thanks.
Okay, thank you. We move to the question of Luis Enrique Perez, please.
Hi, can you hear me?
Hi, yes.
Hi, thank you, Lisa. Your talk was very, very interesting. I think my question was partially answered before, but so I understand that tidal dwarf galaxies are not included in your sample, right?
No, we didn't. No, maybe, but no, we think we didn't concentrate this work in a specific type of galaxies.
Okay, so are you planning to do so in the future, or do you expect something different between these tidal dwarf galaxies,
Yes,
it's just for curiosity.
Yes, no, but we thought about that, and we want to, once we finish this theoretical work, we would like to make some comparisons between the observational information and data we have, and especially from those type of galaxies, because we think that they would be really great candidates. And they are also low mass galaxies. So as this theory tells us that these type of galaxies would be low mass galaxies, we are really interested in studying them and comparing with the observational data.
Okay, that's it. Thank you.
We move to the last question. Felix, if you can be short.
Okay.
Yes, a following up question is, it would be very interesting to know what is the fraction of these tidal dwarf galaxies relative to the other galaxies that will have another origin. This will be very interesting, because it has been proposed that perhaps most of in the past, I don't know what is the status now, but that the majority of the dark matter deficiency small galaxies will be tidal dwarf galaxies.
Yes, yes, and that's why we would like to follow up this investigation and study them. But yes, it would be very interesting indeed.
Okay, well, thank you very much.
Thank you.
You're welcome.
Nicolas can drop the question in the Discord, and other people.
Okay.
We have to move to the next talk. So
Okay.
thanks, Elisa, once again.
Thank you.